All right, in this video, we're going to go over some different types of creative factoring that you may need for, let's say, a pre-calculus or an AP calculus class. So the first example is different types of difference of squares, right? So for example, you are used to something like this with a difference of squares, which would be x minus 3 times x plus 3. Well, can we still do that if the x is not squared? Well, yes, we can, because we can use like this example above, we can say square root of x minus 3 times square root of x plus 3. Because if you distribute this, when we take our first term, root x times root x is x, the outers and inners are going to cancel. So we would wind up with our original x minus 9. So that is just a way of factoring that a lot of students may not be familiar with. Problem 2, we do have a square, but what about if the 5 is not a perfect square? Well, we still have subtraction here. So what we can do in this case is we can use root 5 when we factor it. So we can say x minus root 5 times x plus root 5 as our factoring there. All right. In this case here, we have x to the 16th power, where we can call that x to the 8th minus 1 times x to the 8th plus 1. Now in this case, we still have a difference here with the x to the 8th minus 1, so we can break that down to x to the 4th minus 1 times x to the 4th plus 1 times our x to the 8th plus 1. So again, you can see we still have a difference of squares, so we can what we can do is we can keep breaking that down. So what we would get is, if I get back to my pen here, we can break down the x to the 4th minus 1 as x squared minus 1 times x squared plus 1. And then in the final step, we have a difference of squares here. So we have x minus 1 times x plus 1, and then x squared plus 1, x to the 4th plus 1 times x to the 8th plus 1. All right, so that's something that students may not be used to from, let's say, an Algebra 1, Algebra 2 factoring. All right, so let's look at problem 4. We have a difference of squares, but our first term is actually x plus 5, the quantity squared, so we can call this x plus 5 minus 5 times x plus 5 plus 5. And if you wanted to simplify, this would be x times x plus 10 when we simplify that. All right? Okay. What about 9y minus a to the 4th? So 9y minus a to the 4th. So 9's a perfect square, so we know that's 3. And then we can use root y. So we have 3 root y. A to the 4th is a perfect square, so we can call that minus a squared times 3 root y plus a squared. All right, so that's some different types of factoring with difference of squares that you might not be used to. All right, so what about sum or differences of cubes? All right, so I like to use the acronym SOAP. So SOAP means that if you have a difference of, or a sum of cubes, the plus sign, this is S for same, so it has the same sign here. it has the opposite sign for the middle term of the trinomial, and the last term is always positive. So SOAP, S-O-A-P. So again here, same sign, that's your S, opposite sign, and then always positive at the end. Okay? So what we want to do is we want to take the cube roots of these. Those are going to be our base values. So what is the cube root of 64a cubed? Well, it would be 4a. And what is the cube root of 125b cubed? So that would be 5b. So in this case here, we'd get 4a plus 5b times, and then we have to square 4a, so we would get 16a squared minus 4a times 5b, which would be 20ab, and then b squared would be plus 25b squared. Right? All right, so the next one, take the cube root of this. So this would be 4ax, and then the cube root of 125 is 5. So we would get 4ax minus 5 times a squared. So it would be our term here squared. So that would be 16a squared x squared plus a times b would be negative 20ax. So minus 20ax, and then b squared would be plus 25. Okay. Okay, same thing in this case here. We have the cube root of the x plus 1, the quantity cubed, would be x plus 1. And the cube root of 64 is 4. So again, we're using SOAP. This is the plus sign we're looking at. So it'd be same. So it'd be x plus 1 plus 4 times, and then it would be a squared. So a squared would be x plus 1 squared, and then it would be minus ab. So it'd be minus x plus 1 times 4, and then it would be always positive, so plus b squared. So in this case here, it would be 16. Okay, and then we would simplify this to x plus 5, and then we could leave this as the x plus 1 squared, and then if we wanted to call this, we could just leave this as this. We'll put the 4 out front plus 16. I think that would be a reasonable answer for that. All right. And then in the last problem, now we have a difference of cubes. So we're going to take the cube root of AC cubed. So that's going to be 2C. The cube root of A plus B, the quantity cubed, is A plus B. We have a subtraction. So we're going to get the same sign. So we're going to say 2C minus A plus B times A squared. So it would be 4C squared. Opposite of A times B. So it would be the opposite of that. So we would get plus, and it's going to be 2C times A plus B. And then the final would be always positive. So it's going to be plus A plus B squared. All right, so we would just simplify this. in this case here, I would just, we could just leave it like this. So as long as we get the idea of what we're doing here. All right, so that was some special types of factorings that you may need in a higher level, let's say pre-calc and AP Calc class. So I hope you liked the video. If you like it, please like and subscribe. Thanks for watching.